Let's solve LeetCode 20 valid parentheses. Given a string S containing just the characters opening parenthesis, closing parenthesis, opening brace, opening square bracket, and closing square bracket, we want to determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. So that means if you open with this, you also close with this. Open brackets must be closed in the correct order. That means if you start this, you need to end this. If you start with this and this, then you need to end with this and this. We'll take an example, but this is what they're talking about. And every close bracket has a corresponding open bracket of the same type. Okay, that sounds good. So let's say an input S is equal to an opening parenthesis and a closing parenthesis. The output here is true. The reason for that is because you have an opening and then you have a closing. You don't have a closing, then an opening, right? Then let's take another example. You have input S is equal to this thing. Why is it true? Because if you have an opening parenthesis, it's automatically closed. If you have an opening square bracket, it's automatically closed. If you have an opening brace, you automatically have the closing brace. Cool. Let's take a look at an even more interesting example, which is if you have a opening parenthesis, it's not automatically closed by a closing parenthesis. It's then followed by an opening square bracket, and then it's by the closing square bracket and then a closing parenthesis, and the output here is true. So this is the very important example. That's because it tells us that if you have an open bracket, it is not going to be automatically closed by a closing bracket in the very next character. In the previous ones, we saw that, hey, if it starts with this, it ends with this. So we just have to check the character at i+1 and check if it's equal to I. But no, here there's more to do. You have two different types of characters. So let's say the parenthesis is denoted by 1 and square bracket is denoted by 2. In that case, this will turn out to be 1, 2, 2, 1. And this is the kind of approach we are allowing. If it was 1, 2, 1, 2, that means it was something like this, it would be invalid. That's because you first need to close this out and only then can you close that out. This is the correct ordering. Okay. So how do we solve this? Actually, while just talking about this, I gave you a very big hint of what needs to be done. How I talked about this was something like this. So let's say I have an element here. So I start from here. As soon as I see another character, this case is closed. When I start with this, and as soon as I see this, the case is closed. If I have this and I encounter this, the case is closed. So we are looking to close the particular case as soon as possible. In this case, when we add this and then we add this, or actually so first we have an opening parenthesis, then an opening square bracket, and then we go ahead and finish this case because there's the closing bracket, and then we finish this case because we have a closing parenthesis. In this case, this is the invalid case. We have an opening parenthesis, we have an opening square bracket, and then we have a parenthesis that closes, and then we have a square bracket like that. Obviously, first we need to match the parenthesis with this opening square bracket, and it just doesn't follow stuff, right? So we can't pop that off, and if we can't pop it off, we'll just return false. So that's what we're going for, and that is going to be our solution. Our big solution, as I described here implicitly, is using a stack. So after a stack, we can just keep popping in the opening things. So this stack will contain all the opening brackets. So you have the opening parenthesis. Then as soon as you encounter the closing one, they complete each other and we're done. Then we have an opening square bracket. As soon as we have the closing square bracket, this case is also closed. The same goes for this one. And at the end, if the stack is empty, it's right. If the stack is not empty, it's invalid. let's take a look at the invalid example. So if we have this and this popped in, so not popped in, but appended to the stack. After that, we have this closing parenthesis. We see that, hey, it is a closing parenthesis, but it matches with this one and they're not correct. They're like, this parenthesis is not the closing bracket of this square bracket. And that's the time we will return false, because that's a very big blunder. So let's go ahead and solve this. To solve it, I'm going to create a stack. Then I'll go over every character in the string. And then for each character, what I'm going to do is first check if the bracket is an opening or a closing bracket. And for that, what I'm going to do is define a mapping between the open bracket and the closed bracket. So what I'll do is create a variable called replacement, which just keeps track of an open bracket or a closed bracket with an opening bracket. Why am I doing that? You'll see in just a minute. But let's go ahead and have this a closing bracket to opening bracket mapping. Okay, that's essentially what I'm trying to do here. And the reason I'm trying to do this is because I'm going to check that, hey, if the character is in replacement, so if the character is in replacement, that means we have encountered a case where we have a closing bracket, and we know that whenever we see a closing bracket, for example, in this case, we want to pop out some element. We want to check the last element that was present in the map. So for example, if we had a stack like this and we have a closing bracket now, we want to check with the last element that is present in this map or in the stack, and then check if like they both are opening and closing. And if they are, we'll return, or we'll just pop this off and move ahead. Otherwise, we'll return false. So if the character is in replacement, that means it is the closing bracket that we're talking about. Then we need to check that, hey, I want to compare with the stack. So if the stack is not empty, because it can be the case that the stack is empty, right? Because in the invalid case, the stack could be empty. For example, if we have a string like this, the stack is empty. So what we are doing is checking that, hey, if the character is in replacement, the character curly bracket is in replacement, and then we are trying to access the last element that's present in the stack, and the truth is last element is not present in the stack. So we have to check it. So we'll have if stack and stack at -1. So that gives me the peak or the top element of the stack. I will just compare it with the replacement at character. So this essentially means that I'm comparing. Let's come back to this example. I have the opening parenthesis and then the closing one, right? So if they both match, that means replacement at this. So replacement at the point where the character is this, what will it yield? It will return this particular thing. And stack at -1 already contains this thing. So if that is the case, then what I'm going to do is just return I just want to do stack.pop. That means I want to remove this element out of the array. I'm not returning anything because we still have rest of the elements to go through. It can be the case that we fail further in the string. Cool. Now, if this does not match, that means the stack is not empty, but the character is in replacement. That means no other bracket has been put in. For example, this example, the invalid example, we tried to check if replacement is in character. It's not. It is. The replacement is in character, but the stack is not empty. Then what do we want to do? Because, well, the stack is empty, so you don't have any opening bracket. So what is this being closed for? It's invalid. So we'll just return false, right? And even if the stack is not empty, but if the characters don't match, that means the last element that was put into the stack, which is going to be an opening bracket, and the opening bracket that we get here by using the key to get the particular value. If that doesn't match, we want to return false. And once that's done, we're good. But what if the character is not in replacement? That means it's an opening character that we are having. And if it's an opening bracket, we just have to append it to the stack because there's nothing else to do. We'll simply append it to the stack. And after the entire loop is over, we'll just check, hey, if our stack is empty, then we want to return true, because what happened is that we popped off all of the elements in the stack. So we had a valid ordering, because only in the case of valid ordering will the stack be empty. But if it's not empty, that means something was not popped up. If something was not popped off, that means there was no closing bracket for that. And that is the result which will lead to false. So I will just run it now and we get a runtime error. The reason for that is this expected after dictionary key. I might have messed up somewhere, and yes, I did. I forgot to put in the colon after instead I put in a comma. And this fails. The reason for that is it always returns a false somehow. And I realize my error, it always returns a false because I've made some mistake. It is supposed to be a reverse direction. So if the stack is empty, then we want to return true. Otherwise, we want to return false, right? That's exactly what I said. I just did not type this. So what happened here is that it returned false every time. So it returned correctly false in every single place. So we returned false here, but it returned true, meaning like this condition was reversed. So when it had to return true, it just returned false because our conditions were reversed. So now if I just run it, it works out, and I'll submit. And yeah, it works out. The time complexity is O of n, the space complexity is O of n as well.